Good morning, calculus. Hope you're doing well. This will kind of be the format that we use to attack our pre-calculus review. So first thing we're going to do is look at family of functions. Hopefully the videos work for you. I'm going to move very quickly, so please don't worry about taking notes. You have video on your Chromebook, so you have access to it if you want to take the notes later. I suggest you do, but I'm going to move so fast you won't be able to keep up processing information fast enough, okay? To start off with our pre-calc review, we're looking at graphing, okay? Families of functions. If you'll remember, that means graphing a parent graph, and then all the children are moved left to right, up and down, stretched or shrunk. Okay, so we're going to go over all that. Let's just start with the basic one. Let's go with y equals, say, graph the square root of x. All right. We'll probably extend this down a little bit. Going by ones. So you can see the square root of 4 is 2. And then I just tail it off. Okay, so that's y equals square root of x. This is called our parent graph. Okay. Things that you'll need to know. All right. You need to be able to identify things like domain. Remember, that's the x values. You've been pretty good at identifying those. So what are our x values possible? 0 to infinity. I cannot put a negative inside a root and get a real number output. So in interval notation, we can also write it in this manner as an inequality. Okay. Those are the two most common that you'll see. All right. The range is the y values. Remember, y values again from 0 to infinity. Okay. Yeah, let's rewrite that. Remember that with the bracket, it means it equals 0. Okay, if I were to put an open, it means it doesn't equal that. Okay, so please be aware of that. We introduced it last year in pre-calculus, but let's see. What else do we have to worry about here? Zeros. Roots, x-intercepts, all mean the same thing, just using different contexts, okay? In this case, that is where we intercept the x-axis. So in this case, the x-intercept is x equals 0, okay? The zeros or roots work with functions and equations, all right? So we would, just for our purposes, set y equal to 0 and solve that equation. Of course, we get 0. Okay, so keep this in mind. You're going to use this skill probably as much as anything else this year. All right, so know how to find these numbers and solve these equations. Okay. All right, let's talk about children. What if I asked you to graph y equals the square root of x minus 1? Okay. Remember, if something is paired with the x's, it's going to move along the x-axis. Also remember, we're in opposite land. Okay, so this I'm actually going to, it's -1, but I'm going to move this graph the parent to the right 1 unit. Okay, that's the square root of x minus 1. If I were to put the square root of x plus 1, it would be the other direction. Okay, so keep in mind that we will operate in opposite land there. We can also do y equals square root of x plus 3. Remember, it's outside the x's. Okay, it's not inside the root there. So this is a up and down translation. So I'm going to go up 3. All right. And then I can pair these two together, so I can go up and down and left and right all at the same time. All right. What if we do y equals 1/2 the square root of x? Okay. That is a stretch or a shrink up and down. Okay. The x-intercepts will stay the same, but we're basically cutting this in half. So here, for example, at 1, the square root of 1 is 1, but times 1/2, so we're going to bring it down. Square root of 4 is 2, times 1/2 is 1, and it does that number to it. Okay. Then here's the one that I always have trouble with. Y equals the square root of 2 times x. Okay. This is a stretch or shrink in left or right. Notice it's paired with the x inside the root. Okay. So if I pick an x value of 1, let's do a table. This is, well, let's do 0. Again, the output's going to be 0, but if I choose 1, 2 times 1 is 2, the square root of 2 is 1.414. Okay. What if I choose 2? 2 times 2 is 4, square root of 2 is 2. See how this point moved? Now see how it, and again, we're in the x direction, so we're in opposite land here. Okay, you would think it would double everything and stretch it out this direction, but what it does is actually divides by 2. Okay, so this one is at x equals 2, we move it over to 1. This is at x equals 4, divided by 2, move over to 2. And you're going to see that compression. So it's a compression by a factor of 2. If I would put 1/2 x, it would be a doubling, so it would be a stretch times 2 or a compression times 1/2. Okay, so a fraction is a stretch. This is a compress. You can think of it as kind of a spring. So those are the 4 ways we can move graphs around. All right. I have given you in your Google Classroom a reference sheet. Okay. This has all of the main ones you need to memorize on it. I want you also to memorize sine and cosine. Okay. So I'm actually going to draw these on my paper here in a sec, but y equals x, x squared, x cubed, x to the 4th. Those are your polynomials. And you have your radicals, root and cube root x. This one's very important. This is x to the 2/3. Okay. It comes up a lot. Absolute value x, 1 over x, 1 over x squared. Okay. At the bottom, and something I forgot to mention actually, are the graphing adjustments. I did 3 down. but I did not address 1 and 2 or 7 and 8. Okay. 7 and 8 do come into play. We'll talk about them as we get to them. 1, reflection across the x-axis because it's multiplying the y value by a negative. So you take a y value, multiply it by a negative, you reflect over the x-axis. Reflect the x, multiply the x value by a negative, reflect it over the y value, okay, or the y-axis. So that's your reference sheet. It's in Google Classroom. Let me do, I hope you already have these memorized, but if you don't, sine and cosine this year are probably strictly going to be in radians, real numbers. So we're going to use pi as our reference. And then again, they go from 1 to -1. Okay, and it is periodic, so it will repeat. So sine starts at 0. If you remember from our music project, to 2 pi. Okay, that is one period of the function. You can keep going. It repeats at 4 pi, 6 pi, etc. If you want to come back here, it repeats. Okay. Notice the zeros, 0, or the x-intercepts, pi, 2 pi. Okay. And then y equals cosine x. Here, I'll just do it in a different color. Starts at 1. And then if you wanted to go backwards, you could. Again, periodic. You need to have these memorized because they, one, help you with the values. What's the sign at 2 pi? Well, it's 0. Okay. The other thing you want to look is notice that these are all just shifted pi over 2. Pi over 2, pi over 2, pi over 2. They're the same graph, there's just a shift. Okay. So have those memorized. The domain is the real numbers. The range is 1 to -1. Again, we can start doing things like y equals 2 cosine x. Okay, well that's an amplification or a stretch in the y direction. It'll go from 2 to -2. Same intercepts, it just stretches it. All right. So you have this in your Google Classroom to practice, and I want you to memorize these. So that's why I've given you practice with the same functions on it. Please also add sine x and cosine x, and we'll be good to go. Do it on graph paper. Okay, these are not big enough. So do this on graph paper. If you need some, there's some in the front on the black cart. Okay, but hopefully that's enough practice for you for now. Thanks.